Hey there data people, and welcome back to the lab. Remember when we decided to use SQLite for our DuckLake Catalog but wished we had used Postgres instead? Well, today's migration day. We'll use pgloader to do most of the heavy lifting with a few adjustments to data types, and we'll show you how to reconfigure DuckDB and DBT to connect to DuckLake via DataLab. Let's go! So like I said in the intro, we'll be using pgloader for our migration. pgloader is a tool that lets you load a bunch of data sources into Postgres. One of those sources is SQLite. We'll use our previous state that is on our local directory through our engine DuckDB that connects to all of these catalogs like stage, secure stage, as well as some data marts within local marts. Right, for graphs and analytics. Each of these catalogs will become a schema on our Postgres database, our Lakehouse database, and we'll connect this into our existing DuckLake instance as well. So let's now take a look at VS Code, where we have the migration code implemented as a just command. So we've got this migrate lakehouse catalog all, which will use environment variables to migrate all of these catalogs into Postgres. And the main script that runs for a single catalog will first export these environment variables that will connect to the database, and I'll explain this structure in a second. And then it will configure the SQLite DB path and the target schema for the given catalog. And finally, it will run the migration process. It will build the pSQL connection string from the variables, and we'll use these variables as well, for instance, for pSQL. This is required for pgloader, as you can see. And pgloader will pretty much just get a SQLite database and the target Postgres connection string. We set the schema through the search path over here. First we create the schema if it doesn't exist, and then after we run pgloader we have to do some adjustments to data types, so we run an additional SQL script to adjust this. And we can take a look at this script, which is under scripts DuckLake SQLite to Postgres. So we went through all the data types that were not matching after the migration was done. We created a regular Postgres catalog right from DuckDB and used that to compare the expected data types. And we identified three main data types that needed to be adjusted. One was the timestamps, which are stored as varchar on SQLite, and they are converted to text by pgloader. So we just had to run this alter column type to timestamp tz using this simple cast. It's already in the correct format. And for some other tables, we also had UUIDs and Boolean types. For UUIDs, we had to follow a similar approach. We just did a regular cast. And for Booleans, we first cast to integer to make sure the source variable is an integer, although it's already stored as a big int on SQLite, which is really just the integer class, and we compare to 1, and this will use true when it's 1, and all of this is just essentially converting these three data types for the affected tables, which are 10 out of 22 tables that make up the structure for a DuckLake catalog. Can find this on the website for DuckLake. So if you go into DuckLake select, and if you go into the specification, you'll be able to find tables over here. You got an overview of these tables, and if you click into, let's say, schema, which will correspond to DuckLake schema, which is this table, you'll find all the details of the types that are meant to be used, although they get converted to something else in SQLite, because SQLite works slightly differently. So if we go into the documentation for SQLite and check the data type page, you'll find that there are only these storage classes. You only really store null, integer, real, text, or blob. That's it. But then you have more complex data types. So you can parse date and time from text, real, or integer. There really isn't a specific type for timestamps. You can represent these as any of these types. And then you've got what is called type affinity. And type affinity, let's go into some examples. For instance, you can use any of these types, and these will be converted into the target affinity. For instance, if you use big int, you are really just converting to the integer affinity. This is not a data type. An actual data type is the storage class. Because if you look down here, you'll find this numeric affinity, and numeric is not a storage class. For instance, boolean will be stored as numeric, and numeric can either be an integer or a floating point, so it will decide depending on the value that you insert. And when we insert booleans, they are really converted to integers. So a bit of weird type foo is happening here on SQLite, and that's why we have to do additional conversions. If you go into the overview here at the bottom, you'll find the DDL for creating the schema. What you'll find here is essentially the equivalent to the Postgres version. So you've got timestamp TZ, you'll find boolean values as well, and you'll find UUIDs somewhere, as you can see. So in order for our just file to be able to run the migration, we'll need to first set the environment variables for our PostgreSQL database so that we can connect and know which schemas will correspond to which catalogs. And we'll also need to have the environment variables that define the paths to the each of the SQLite catalogs. So we'll have this StageDB, EngineDB, Secure StageDB, etc. And now let's take a look at the format for our environment file. So what we had before was just this block. This is now deprecated. We still use DuckDB as the compute engine, but we will no longer be using this. But however, we need this to be present at least until we do the migration. Then you can delete this. And then we just set up our PSQL catalog variables here with the host and port for the database, the DB name, we're using Lakehouse here, and the user and password. And then we set the schemas for each of the catalogs. Once we do that, we can simply run just migrate catalog all, and this will update our SQL database. So let's first do a clean run, and for that I'm going to delete our local catalogs. As you can see, it's been deleted. I'm also going to delete init.sql, and we're gonna go into min.io as well. And for the Lakehouse bucket, we're going to delete everything except raw, which is where our downloaded datasets unprocessed are. And now we'll go into here and just check out this before PSQL, which points to the last version where pSQL is not active, and we can run a global TL, which will ingest everything using the SQLite catalogs, or rather do all the transformations. And we are done, and we can check to see that the catalogs have been recreated over here under marts as well. If we connect to our lakehouse, because we deleted the init SQL, it will be regenerated for SQLite. Now we can check that our stage tables, for instance, are here, as we can see, and we can even select, for instance, some data. If we go back into the browser and refresh this, you'll see that this has also been recreated. So our files are here, our Parquet files, our data, while our catalog is now running on SQLite. Now let's run the migration process, and let's first make sure that we have our configurations, and we do have our database configurations over here, but we do not have any configs for Postgres. So let's go back to our dev version where we have all that, and let's make sure that it's here. As you can see, we have our configs here. First, let's log into the database to make sure that so we've got our lakehouse database, make sure there are no schemas, and as you can see, we only have the public schema here. And now we can run our migrate lakehouse catalog all. As you can see, it is running a PG loader, and these alter tables that you see here are the type fixes. And now if we connect to pSQL again, as you can see, there are several schemas here. Let's pick one of these, let's say graphs, or rather stage, because that's the one we were looking at before. And now we can find all these tables here for the catalog, of course. And so, for instance, let's select from DuckLake table, and we'll find, let's just select the table name, which makes it easier to read, and we'll find that these tables are tracked here. Now, because we are already on the development version, the latest one, let's run generate init SQL again, and this time it will generate the init SQL that will connect to the Postgres catalog. And as you can see, a good indicator is that it finds the data marts as pSQL catalog in vars rather than the regular SQLite vars. Now if we run just lakehouse, we can run show tables from stage, and the tables are still here. And now let's look again at some data. As you can see, the data is here. Now, just to make sure that this worked, let's delete all our catalogs from SQLite that were local. Let's do this again. And as you can see, we were able to successfully migrate this. Let's just quickly take a look at the data types for our tables on Postgres. So if we go into the lakehouse, we'll find all these tables. Let's go into stage, for instance, and as an example, let's look at DuckLake snapshot, and you can see snapshot time is a timestamp with time zone. Or if we look, let's say, at DuckLake table, you'll find that table UUID is correct type, and that path is relative is also the correct type. So now let's talk about what changed on DataLab so that we are able to connect to the new PostgreSQL catalog. Let's take a look at the log for Git. And this is the commit where the migration happened. And these are the files that were affected by the migration. But the main files that we are going to look at is share templates, which contains the template for the init.sql file, and transform profiles, which contains the configuration equivalent to the init.sql, but for dbt. So if we go into shared templates, we'll find that we've got templates for each attachment, so each catalog, and we've got the global template which creates the secrets. So if we go into this one, we'll see that now we have this metadata schema, which sets the Postgres schema where this catalog is, and we have got this DuckLake column without any more information, which means that we are using the default secret to configure everything else. This is the same, but it's for the encrypted catalog, the secure stage catalog. In here we replaced SQLite with Postgres. We keep our min.io secret, this is unchanged, and then we added this Postgres secret where we use our environment variables essentially to set this up. And then we create the default secret, which is used in the config in here when we are doing attachment to DuckLake. As you can see, it's type DuckLake. You need to set a metadata path. We use an empty path here. And then we use this metadata parameters map with type Postgres that points to secret Postgres. So this is the name secret Postgres that you see here, which means that this DuckLake will be configured to connect to Postgres as the catalog. Now, if we go into transform and open the profiles file, you'll find a similar configuration. So we also replace SQLite with Postgres over here. We keep this secret, and then we add the Postgres secret and the DuckLake secret. This is very similar to the configuration you just saw, but in here we didn't use any names for our secrets. We now do, because we need to mention this secret by name, and we just, for consistency, we added a name to all of these secrets. And then for each catalog, the configuration is similar to what you saw yet again. Once you do that, you are able to use to run your dbt transformations directly into DuckLake using a Postgres catalog. And finally, let's take a look at our application, our ML server, which depended on our DuckLake being usable from within the DataLab infra. And you can check the DataLab infra video series if you want to know more about that. So if we go into infra apps in Docker, we'll find our deployment for our ML server, which is just runs the LCTL ML server essentially. And then we've got our compose file, which previously only contained these two environment variables, but now that we have DuckLake working, we also added the configuration for S3, and these variables, keep in mind, they should be available as CI/CD variables. There is no .env when you are running this from CI/CD. So if you need to update your CI/CD variables, just go into services, GitLab, and just run Terraform apply, because this will update your variables from your .env on GitLab. So going back to the compose, we also set the S3 buckets for all of our catalogs, exports and backups as well. And finally, we set our PostgreSQL catalog variables with the schemas as well as the connection data. And that's it. Once you have this running, you can commit and push to infra if you're running GitLab. If not, you can just Docker compose up locally. And let's just go into the browser and test whether this is actually working. But first, let's just check our lakehouse to make sure that the secure stage, because this is user data, or the inference results hasn't been created yet. So this table doesn't exist. Okay, and now let's go into the browser so that we can connect to our service. I already have it here. So let's try and do a prediction. We're going to use the XGBoost model with TF-IDF, the latest version. And keep in mind, this is connecting to MLflow. There's an MLOps end-to-end video about how to set this all up, if you're interested. This is to classify depression, so let's say we are happy today. And let's make sure that we set log to lakehouse to true. We execute this, and as you can see, there is a result that comes back. The logging was sent to Kafka, and so we can force flush by running this request. And once this is done, we should see some output on this table over here. And as you can see, I just clicked it twice because so we have two outputs. We have two logged inference results that ran on top of our PostgreSQL catalog using DuckLake and running completely on our DataLab infra. So our data stack is now complete. And there you have it. Hopefully you found this video useful. In the next video we'll start working on something a little different. We're gonna start building a cool little object store in Go to replace min.io on our DataLab infra. You might learn a little Go and a few details on how object stores work. As usual, this week's blog post is available at datalabtechtv.com. Follow the channel on Blue Sky for updates and join Discord if you have any questions. Don't forget to drop a like and subscribe for all things data.